Hello, good day everyone. Welcome again to Integral Calculus. And for today's video, we would be discussing about the integration of rational fractions. So suppose that you would be integrating this rational fraction right here. So the first thing that you would be doing is to check if this certain equation right here can be solved using our basic formulas that is listed right here. So if you can solve for it, using these equations right here, then solve for it that way. But suppose that you would be getting an equation wherein you cannot use any of these formulas right here. It is then where we would be proceeding to these steps right here. But let's go back to this problem right here first. So as you can see, these terms right here on the numerator part is exactly the differential of this term right here, which follows this format right here. So the integral of du over u. Since if this is to be our u, so u is equal to x squared minus x minus 6. And if we are to get the derivative of this equation right here, this is to be equal to du is equal to, so what is to be the derivative of this? This is to be 2x dx. What is to be the derivative of this? This is to be minus dx, then minus 0. And simplifying this is to become, so 2x minus 1 times dx, which is exactly this one right here. So if this is to be the case, so the integral of a certain du divided by u is to be equal to ln u, or the natural logarithm of u, plus c. So from that, our answer for this particular problem right here is to be equal to the natural logarithm of x squared minus x minus 6 plus c. So this is to be your final answer for this particular problem right here. But once again, what if we are to deal with a rational fraction wherein this is not to be the case, or let's say that we cannot use any of these equations right here from the very beginning or from the very start? So it is then where we would be making use of these steps right here. So one example of it is to be this problem right here. We are to get the integral of dx divided by x squared plus 2x. So as you can see, if your u is now to be equal to x squared plus 2x, so if you would be getting the du of it, or the derivative of it, that is to become 2x plus 2. And 2x plus 2 is nowhere to be found in the numerator part. Thus, we cannot use the logarithmic formula for integrating, or any of these formulas right here in particular. So once again, what we would be doing is that we would be following these steps right here. So in these steps, the first step in the integration of rational fractions is to check if it is an improper fraction. So if this one right here is an improper fraction. So if so, you must carry out division, then resolve it into partial fractions in the remainder part. So we would be having an example of this later. But if it is a proper fraction, which is this one right here, proceed with the resolution into partial fractions. So you can say that your rational fraction is an improper fraction if the degree of your numerator is higher or equal to the degree in your denominator. And as you can see here, there is actually a hidden x raised to 0 here, which is equal to 1. So meaning the degree in the numerator side is equal to 0, and the degree in the denominator side is equal to 2, which is this one right here, thus making this fraction right here a proper fraction. But for pretend that the degree here is to be equal to 2, and the degree here is also equal to 2, what you would be doing is that you would be dividing this fraction right here via long division, or any known method in algebra. So there. For number 2, we must resolve the rational fraction into its corresponding partial fraction. So your partial fraction can be categorized in these cases right here. The first case is to be the distinct linear factors. The second case is to be the repeated linear factors. The third case is to be the distinct quadratic factors. And the fourth case is to be the repeated quadratic factors. And as you might have known already, all of these topics right here are under your advanced algebra. So the prerequisite subject for this topic is to be that of partial fractions in your algebra. And that is for step 2. For step 3, what you would be doing is to evaluate the integral of the equivalent partial fractions using any integration formula needed, such as these formulas right here. So basically, the integral calculus part of this subject matter is just to be step 3. As for your steps 1 and 2, these topics right here are from your advanced algebra, which is, well, getting the partial fraction of a certain rational expression. So let's just do this example right here instead. So given this equation right here, so we would be getting the integral of dx over x squared plus 2x. So what we would be doing first is to check if this fraction right here is a proper or an improper fraction. And like what I have said earlier, this one right here is a proper fraction. Thus, we will be proceeding to this step right here right away, which is to resolve the rational fraction into its corresponding partial fraction. Okay, but for us not to get confused, I would focus first in the integrand part. And for that integrand part, it is better for me to get rid of this integral symbol right here and this dx right here first. So let's focus first on the integrand part. So I am doing that just for me not to get confused. But if you want to do it alongside these symbols right here, then it would be better. But once again, I would just be getting rid of them for me not to get confused. The integrand part can be rewritten as, so 1 divided by x squared plus 2x. So what I have written here is just the integrand part. So after getting the partial fraction of this particular rational fraction right here, we would then introduce these symbols right here since we are to get the integral of this partial fraction right here. So there, and for me to get the partial fraction of this one right here, so the next thing that I would be doing is that I would factor this denominator part into its simplest terms. So from that, this is now to be equal to 1 divided by, so if I am to factor out x in this denominator side right here, this is now to be equal to, so x times x plus 2. So once again, what I did here was just to factor out your variable x. So 1 divided by x times x plus 2. So I would just be moving this in the bottom part for us to have space. So the next thing that we would be doing is that we would now write its equivalent partial form or partial fraction form. So from that, we would be introducing the coefficients a and b. So for your coefficient a, so let's say coefficient a, and we are to divide this with our first factor, which is x. So there. And as for the next one, let's introduce the coefficient b divided by our second factor, which is x plus 2. Okay, so for pretend that we still have another factor right here, so let's say that there is to be the presence of x minus 3 here, we would once again be introducing another coefficient, let's say c, divided by x minus 3. That's if you have this factor right here. But since we do not, then we don't need to add another coefficient c. So I would just be removing them. Okay, so after that, the next thing that you would be doing is to multiply all of the equation by this one right here. So that is to be x times x plus 2. So from that, let's multiply it once again to all of the terms here. So for this part right here, so 1 divided by x times x plus 2 times x plus 2. So this would just simply cancel out. So this is just to be equal to 1. So equal to, so what about for this term right here? So a divided by x times x plus 2, this would just simply cancel out, which is x and x. So this is now to be equal to a times x plus 2. So we have this one right here. And as for b, so plus b, so x times x plus 2 divided by x plus 2, this one right here would just simply cancel out, thus giving you an answer of x. So there. And the next thing that you would be doing is to solve for the coefficients a and b. But how can we solve that? So we can solve for this one right here by substituting a value of x that would get rid of the other term. So for example, that I want to solve for this value of a right here, I would now substitute x be equal to 0. So why am I doing this? So I am doing this to get rid of our value for b. Because if we substitute x equal to 0, then this term right here would be multiplied by 0. Thus, this is to be removed. So from that, solving for a, so this is to be 1 is equal to a times 0 plus 2. So times 0 plus 2. Solving for a in this term right here, this is now equal to 1/2. So this is for your value for your a. And how about for our coefficient b? So this time, let us substitute x be equal to -2. So once again, why am I doing this? I am doing this to get rid of our coefficient a, to solve for letter b, or our coefficient b. So from that, this is now to be your equation. So 1 is to be equal to a times -2 plus 2. So this is now to be equal to 0. And 0 times a is equal to, well, 0. So plus our value for b times x. And our x, once again, is equal to -2. So -2. Now solving for b. B is now to be equal to -1/2. So this is to be, these are to be your values here. And now that we have both of these coefficients right here, the next thing that we would be doing is to substitute them in this partial fraction form right here. Okay, so since this is to be your partial fraction form, we are now to substitute these values right here to this partial fraction form in this part right here. So this is now to be equal to, so 1/2 divided by x plus 2 plus -1/2, which is your value for b, so -1/2 divided by x. So from that, let's simplify this. So this is to be 1 over 2 times x plus 2 plus, minus 1 over 2x. So this is to be your partial fraction for this term right here. So once again, this is to be the equivalent of this particular fraction right here. And since that is to be the case, so for the integral of dx divided by x squared plus 2x, this one right here can be rewritten as, so this is to be the integral of this one right here, which is, well, dx divided by 2 times x plus 2 minus dx divided by 2x. So once again, I have just reintroduced this integration symbol right here and dx. So this one right here is basically this one right here. So from that, since this one right here are already simplified, and since, as you can see here, we can now use our basic integration formulas, we can now solve for them. So this is now to be equal to, so the integral of dx over 2 times x plus 2 minus the integral of dx divided by 2x. So let's go right here once again. So this is now to be equal to, so 1/2 integral of dx over x plus 2 minus 1/2 the integral of dx over 2x. Oops, I'm sorry. So this should be x. Okay, so we can actually solve for this ones right here using this equation. So from our basic formulas once again, the integral of du over u is equal to the natural logarithm of u plus c. So as you can see here, if this is to be your u, this is to be your du. So if you would be getting the derivative of this term right here, it would give you exactly this answer right here. And if we are to get the derivative of this one right here, you would be getting exactly this value right here. So from that, we can just write it this way. So this is to be equal to 1/2 times the natural logarithm of x plus 2 minus 1/2 times the natural logarithm of x. So this is to be its corresponding answer. So if you want to simplify this further, so you may do that. So you can just factor out 1/2 here and there. So let's just do that instead. So this is to be equal to 1/2 times the natural logarithm of x plus 2 minus the natural logarithm of x. But don't forget, guys, the arbitrary coefficient c. So plus c. So once again, this is to be your final answer for this particular problem.